In this tutorial, we're going to use the drawing and layout tools in Aspire or V-carve Pro to design this open sign. We're going to use the drawing tools from the drawing tab on the left hand side of the interface and also import a piece of vector clip art for the actual open sign in the middle. We're then going to move on and calculate toolpaths. So we'll calculate toolpaths for the flat bottom V carving to leave the open sign raised. We'll also calculate drilling toolpaths, a chamfered edge toolpath, and also a final toolpath to cut the sign out but leaving tabs in place. The first thing I need to do is close this file. So File, Close. You'll see here that we're using V-carve Pro for the tutorial, and the procedures and techniques are exactly the same for both V-carve Pro and Aspire. We're going to create a new file. So a new file, specify the size of the design or size of the sign that we're going to carve. In this case, we're going to create a 15-inch by 10-inch file using 1/2 inch thick material. Z0 to be on the surface of the material. This is the point that you would reference the tip of the cutter on the control software. So Z0 is on the material surface. We want the X, Y origin to be in the middle of our piece of material. So the faint or light grey lines shown in the two-dimensional view, where they cross, this is X0, Y0. And click OK. So the software has opened the drawing tab on the left-hand side of the screen, and we have our two-dimensional drawing view. I'm going to start by drawing some simple ovals. I want the ovals to be at X0, Y0. We'll draw the first one 12 inches wide by 7.5 inches high and create. Let's draw a second one slightly larger, 13 by 8.5 inches and create. So there we have our, close the form, two ovals. Next thing, we're going to import a piece of vector clip art for the open sign to sit in the center of the sign. So to do that, we say import vector data. We can import DXF files, DWG, EPS, Adobe Illustrator, vector data from PDF files, and also file formats from the other Vectric products. You'll see here in the sample files folder, there's an EPS file called opensign.eps. We open this, you'll notice that the file gets opened in the top right hand corner. The open sign vector data has been drawn in the same position that the graphic designer drew it, which is not in the right position for us. Now we can click a second time and click and drag with the left mouse button to drag the information to the required position, or we can use the Align Centrally Material tool. So align centrally, and you'll see that the open sign jumps to the center of our sign. We can change the size of it by clicking on the little white handles here. So I can click and drag to change the size. If I hold the Shift key down, it scales relative to the center of the selected vectors. So we can click to an approximate size. If we want this to be an exact size, we can say scale the selected vectors. In this case, let's make it 9 inches wide. The height is scaled proportionately, and apply. Close the form. So the distance across there is exactly 9 inches. We're now ready to calculate our first set of toolpaths. So we're going to swap from the drawing tab on the left by clicking the switch to toolpath tab icon to the toolpath tab on the right hand side of the screen. Just check the material setup. So we're going to use 1/2 inch thick material, Z0 on the origin, a retract or clearance height of 0.2, and at the end of the machining we want the cutter to retract 1 inch above the material. Click OK. We're going to calculate what's called a flat bottom or a flat bottom V-carve toolpath or an engrave toolpath. So we're going to machine, drag and select the open sign. If we just machine inside those selected vectors, we'd have a negative or an engraved toolpath inside each of the letters. If we hold the Shift key down and select the inner oval, the toolpath will now be calculated from the edge of the oval up to each of the letters. We're going to cut the toolpath 1/4 inch deep. We'll use a 90-degree V-bit cutter to get the detail. But because we've got some large flat areas here, we're going to initially use what's called a flat bottom area clearance tool. For that, we'll use a 1/4 inch end mill. So we've got the oval selected and the open sign. We're going to say calculate. This gives us 2 toolpaths. First toolpath is the toolpath for the end mill. So click and drag the left mouse button to twiddle. The preview form is automatically opened, so preview this toolpath. This shows us the material that will be removed by the 1/4 inch end mill. If we add some color to this toolpath, so dark red, click with the right and push with the right mouse button, you'll see that the 1/4 inch end mill is too big to pick out any of the detail around the lettering. So we would then change the cutter to the V bit or an engraving cutter, and this will machine where it needs to give us the finished detail. So we say preview this toolpath, and you'll see it's chamfering the edges on the open sign logo. And if we give this toolpath some color, so the same color, you'll see that would be the result of cutting this particular sign using these 2 cutters, 1/4 inch end mill and the 90-degree V-carving bit. We're now ready to calculate another toolpath to machine a chamfered edge around our sign. So I'm going to say close the preview form. We go back to the drawing tab, so switch from the toolpath tab on the right to the drawing tab on the left. Now here we have the 2D view and the 3D view, and we can swap between these in the top left hand corner here, or we can tile the 2 views. So tile the views, so split them horizontally, so we have the 2D view and the 3-dimensional view. Makes it much easier to select different vectors and see what the results are in the toolpath view. So now we're going to select the outer oval, swap back to the toolpath menu, calculate a profiling toolpath. We'll cut it 1/4 inch deep. We'll use the same 1/2 inch diameter 90-degree V bit. We'll profile around the outer edge of this selected oval and calculate the toolpath. You'll see that the toolpath's been calculated around. If we zoom in the 2-dimensional view, this is the selected vector. This is the center line for the toolpath. So the toolpath is cutting on the outer edge of the oval, and it's going in a counterclockwise direction. If we preview this toolpath, so preview, that would be the result. If we add some color, let's make this a dark bluey greeny color. If we click and twiddle with the right hand mouse button, zoom in, you'll see now we've got a little chamfer around the outer edge of our sign. Next, I need to draw some circles to drill some mounting holes. So to do that, we close the preview, go back to the drawing tab. I'm going to draw I'm panning by clicking and holding the roller mouse button on my mouse, clicking and holding, and it will pan around. So we're going to draw a circle here and a circle here. So to do that, we very simply say draw a circle, 1/4 inch diameter. Now we can click in the 2-dimensional view and it will draw a circle for us. If we click on the other end, it will draw another circle. While we've got this one selected, if I say this circle needs to be at 6.25 inches negative in the X dimension and on the Y axis, and apply, it will jump to the exact position. If I click on the right hand side, we want this one to be plus 6.25 inches and also exactly on the Y axis. So apply again and it's jumped into position. Close the form. Now if I click and hold the shift key to select both of the little circles, we swap to the machining toolpath, the toolpath tab on the right hand side of the screen. This time we're going to calculate a drilling toolpath. So create a drilling toolpath. We're going to drill all the way through our piece of material. So I'm going to actually drill, say, 30 thousandths deeper than 30 thousandths through the material. Let's select a tool. So in this case, we're going to use a drill. We'll use a 1/4 inch drill bit. Here we specify the size of the bit, the pass depth. So here we're saying cut 1/4 inch pass depth. So we'll end up with 3 passes, one at 1/4 of an inch deep, another one at 1/2 an inch deep, and a final pass cutting to full depth. This is the spindle speed and the feed rate that we plunge at. Calculate the drilling toolpath, and the toolpath will be calculated at the center of the selected circles. The software is now warning us that this is going to cut 30 thousandths deeper than my material. Is this okay? If you've got some sacrificial board on the table of the machine, this is okay. If you were cutting onto a steel bed, then you probably wouldn't accept this. So we'll click OK. The toolpath has now been calculated for us. If we preview the results, we'll see there's the toolpath drilling the holes, the mounting holes for us in the edge of the sign. Next, we're going to cut the sign out. So we're going to profile machine around the outer edge of the oval to cut the sign free. So we close the preview view, go back to the profile machining tab. So profile, we're going to machine all the way through the material. So 1/2 an inch. Let's make it 10 thousandths deeper to make sure it cleans through. Select the tool. Let's say we're going to cut the sign out with our 1/4 inch end mill around the outside. So now if I say calculate, the software warns me that the toolpath is going to cut through the material. Click OK. And there's our toolpath calculated. You'll see here in the 2-dimensional view, the toolpath has been offset around the outermost edge by the radius of the cutter. If I double click to edit this toolpath, let's give this a different name, so just to make it clearer. So we'll say cut out. But I don't want it cutting right up to the edge because we have a chamfer here. So I'm going to say I want an allowance on there of say 150 thousandths, so it will cut further away. Plus, we say F to zoom to fit. What I really want is we want to add some tabs to this project. So instead of cutting all the way through and finding that the sign breaks free, I'm going to say add some tabs that are 1/2 an inch long, 1/8 of an inch thick. Edit the tabs. And so I automatically want the software to place 4 tabs equally spaced on the, sorry, we just need to select the outer oval there. So we'll say edit the tabs. We want 4 to be equally spaced. So the little green nodes represent where the tabs will be placed. Calculate. Yes, we're happy for the toolpath to run. If we maximize the 3-dimensional view, you'll see the little bridges there. These are the tabs that are going to hold the sign in place. If we preview this toolpath, you'll now see that we've got 4 tabs that are going to hold the sign in place and stop the sign from breaking free. So just to summarize, if we go back to the drawing view, so 2-dimensional view, we've drawn some ovals, we've imported some clip art and sized the clip art, we've drawn some holes for the drill holes. We go back to the 3-dimensional view, swap to the toolpath tab on the right, preview, reset the preview. So we've got a toolpath that's going to pocket machine using our 1/4 inch end mill. So preview that toolpath. We would then change the cutter for the engraving bit or the V-carving bit to give us the detail. Run that toolpath on the machine. This will give us the very precise and decorative 3D V-carving or engraving toolpaths. We then profile machine a chamfer around the sign. Drill some holes. And finally cut the piece out. But instead of cutting all the way through, we've added little bridges that are going to hold the piece, hold the project in place and stop it breaking free. When we're happy with the toolpaths, we'd say close. We can estimate the machining time. So the software is estimating that it would take us about 18 minutes to machine this sign. We get an estimated time for each of the different toolpaths. Close the window. we can then save the toolpath. So save toolpaths, select each toolpath in turn, select the post processor for your machine, save the toolpath, give it a specific name, and it's ready to run on your CNC machine. Thank you for watching the tutorial.